Okay, this should be the last video, I hope. This is just a long section. It would take all hour easily in class, if we were doing it in class. So, all right. Looking up at the top here, it says, when two statements are both true or are both false, they are called equivalent statements. Basically what that means is, remember, a statement can only be true or false. It can't be both. Basically what this is saying is that if you've got a statement written in different ways, maybe one's a converse compared to the original conditional statement. If they are both true, even though those statements are worded differently, they are equivalent statements because they are both true or they are both false. Okay, they have the same meaning, but they're written differently. Okay, so now, look in here. This is a definition. I definitely want you to add this to your notes. This is something that we're going to be using a lot throughout the year. If two lines intersect to form a right angle, then they are perpendicular lines. Line L and line M. If two lines intersect to form a right angle, remember that little square means it's a right angle, then they are perpendicular lines. So this is what you're looking at in a picture. What you'll see as far as notation is this. It's like an upside down capital T. Line L is perpendicular to line M. This is the notation and how you read it. Line L perpendicular to line M. It's an upside down capital T. It means the lines are perpendicular, which means you have a right angle, which means you have a 90-degree angle there. Okay? So, is that statement true or false? If lines are perpendicular, do they form, if two lines intersect to form a right angle, are those lines perpendicular? Yeah, of course, that's true. All right, now I want you to write the converse. So go ahead and try that on your own. Hit pause. All right, write the converse of the statement above. So converse are flippin' sweet shoes. So we're going to switch the hypothesis and conclusion. If lines are perpendicular, then they intersect to form a right angle. Is that statement true or false? If lines are perpendicular, do they intersect to form a right angle? You bet. That is a true statement. So now what we have is an if-then statement and its converse that are both true. So these are equivalent statements. Basically means we could read it either way and it's still good. It's still true. It means the same stuff. So down here, you can write a definition. If, that's a big if, the conditional statement, that is what we started with up here, and bold and in red, it means it's important. So if the conditional statement and the converse are both true, if that situation happens, you got a definition. And that's what we're kind of talking about with this. If we're going to try to define something, we got to say things properly. We got to have this kind of statement with it. If then is true, and if we switch it around, it's still got to be true. All right. A definition means if you have this thing, it's got to be this other thing. If the hypothesis is there, if the drawing is correct, then you've got to have this proper information. If you have this proper information, think about the converse. If you have this proper information, then this drawing has to be the way it is. Okay, that kind of thought process. You can go in either direction with the statement, whether it's the original or the converse. If they're both true, you've defined whatever this thing is. All right, so a new kind of statement. It is called a biconditional statement. And it's a statement that contains the phrase if and only if. Okay, that kind of leads towards it's the idea of a definition. This thing is whatever it is, if and only if you have this stuff happening. You can write a biconditional statement if the original statement and the converse are both true. Okay, so basically we're going to use this kind of a biconditional statement. We're going to use it to define things. So it says in the example, write the statement, adjacent angles share a common side, as a biconditional statement. And I guess before we do that example, let's go back to back up to the top here. Basically what your statement is going to look like is the hypothesis, if and only if, and then your conclusion. All right, and because you could read it in either direction, that's kind of what the if and only if means. You could write if the conclusion, if and only if the hypothesis. It means the same thing because the original statement and the converse were both true. But this is what our statement is going to look like. All right, so back to the example. It says, write the statement, adjacent angles share a common side, as a biconditional. Angles are adjacent. Again, I'm changing the words around just to make it kind of flow better as a sentence. Angles are adjacent if and only if they share a common side. That is our biconditional statement. And that's the definition of adjacent angles. Angles are adjacent if and only if they share that common side. That's what our definition for that thing says. Okay, that is it. Sorry that took so long, but it was necessary for all this stuff. See you tomorrow. Bye.